So in this video, we're talking about how to find the special angle values with reference angles and reference triangles. So we have our two reference triangles. I'll put them here. The first is a 45-45-90 triangle, and the second is a 30-60-90 triangle. So we've done a bit with these now, and hopefully you're becoming a little familiar with them. So part of this video is going to be talking about reference angles. And so I just want to make that connection right here that the 45-45-90 triangle is always used when you have a reference angle of 45. Then the 30-60-90 triangle is used whenever you have a reference angle of 30 degrees or 60 degrees. I'm saying everything in degrees here, but you could do radians too, of course. So, okay, what is a reference angle anyway? So if we look at our unit circle here, just labeled with our special angles, we would say that an angle's reference angle is the angle it makes with the x-axis. Okay, so what does this mean? If we look at 30 degrees, the angle it makes with the x-axis is just 30 degrees. So we draw that angle down and we're 30 degrees. But if we look at 150 degrees and we draw down to the x-axis, this is also 30 degrees. So it's 30 degrees away from 180 degrees. So we would say that the reference angle for 150 degrees is 30 degrees. We could do the same thing for 210 degrees if we draw a line up to make a triangle to the horizontal axis, the x-axis. We are 30 degrees past 180 degrees. And same for 330 degrees. If we draw our triangle up to the horizontal axis, we're 30 degrees from 360 degrees. So this means that 30 degrees, 150 degrees, 210 degrees, and 330 degrees all have a reference angle of 30 degrees. So that we would always use the 30-60-90 triangle when working with these angles. And we would draw it in the similar way here that I've drawn. It's sort of like a bow tie shape. So this is going to help us when we're solving problems to have it laid out this way and to really orient us in the correct quadrant. So with the 30-degree angles, you might notice that all of these angles in radians are divided by 6. They all have a denominator of 6. So whenever you have an angle over 6, you can assume that we're using the pi over 6 reference angle and corresponding the pi over 6 reference triangle. So in radians, it's actually pretty nice to know what the reference angle is. All right, let's try this again. So if we have 45 degrees, we could draw a triangle down to the horizontal axis and we'd just have 45 degrees. So the reference angle is itself. But if we look at 135 degrees, we would draw a triangle down to the horizontal axis and we would have a 45-degree angle in this triangle. So 135 degrees is 45 degrees away from 180, so that angle for the triangle is 45 degrees. Similarly, for 225 degrees, if we draw a triangle up to the horizontal axis, we have a 45-degree angle there in that triangle. We would say that 225 is 45 degrees past 180 degrees. And then lastly, 315 is 45 degrees from 360 degrees, and so we would draw that triangle up. This means that we would use the 45-45-90 reference triangle anytime we're working with these angles, and I would draw it in this type of position to help me get it in the correct quadrant. Also, if we look at 45 degrees, and we notice that all of the radians are divided by 4, they have a 4 as a common denominator, we would know that any fraction in radians that's over 4, so pi over 4, 3 pi over 4, 5 pi over 4, or 7 pi over 4, those are all going to use pi over 4 as the reference angle. Then I'll just breeze through this part, but we would do the same thing for 60 degrees. So 60 degrees, 120 degrees, 240 degrees, and 300 degrees all use the reference angle of 60 degrees. So anytime we were using these angles, we would use the reference triangle of the 60-30-90 triangle. But we would orient ourselves with the 60-degree angle part of that triangle. And like I said, for the other cases, because all of the 60-degree angles are divided by 3, we're going to know that these would use the pi over 3 reference angle. So again, the radians is actually, I think, a little easier because you can just look at those denominators. Okay, so given this idea, let's practice finding some reference angles. And we're going to try to do this without looking at a unit circle. So I'm just going to test you a little bit to think about these values and how you can relate them to the unit circle without looking at it, just to really get that connection in your brain. So let's find reference angles for the following: 2 pi over 3, 5 pi over 4, and 300 degrees. I'll do the first one with you, and then you can try the other two. Okay, so for 2 pi over 3, this is an angle in radians and has a denominator of 3. So 2 pi over 3, this corresponds with a reference angle of pi over 3. Now let's say you forgot this trick, and let's talk through the reasoning. So in my brain, I'm trying to figure out where this angle is. Where is it without looking at a unit circle? So I like to think about pi. Pi is 3 pi over 3. 3 over 3 is 1, so pi is 3 pi over 3. And so 2 pi over 3 is just 1 pi over 3 less. So it's 2 pi over 3 instead of 3 pi over 3, if that makes sense. So if we were to draw ourselves a little sketch, 2 pi over 3 is closer to pi, it's just pi over 3 away. So we would do 2 pi over 3, and pi over 3 would get us to pi. Okay, so the reference angle is pi over 3. Now, why don't you try this with 5 pi over 4 and 300 degrees? Okay, so for 5 pi over 4, if we use our pattern that the denominator corresponds to the reference angle, we would say that the reference angle is pi over 4. So again, we're going to do my same reasoning though by looking at pi. So pi would be 4 pi over 4. 4 over 4 is 1, so 4 pi over 4 is 1 pi. And so if we have 5 pi over 4, this is 5 pi rather than 4 pi, and so it's 1 pi over 4 past the pi mark. So okay, we can say with our little sketch that 5 pi over 4 is in quadrant 3. We go pi over 4 past that horizontal. So I like this because reference angles always refer to that horizontal. So if I think about pi and where it is in relation to that, that helps me sketch it out. Again, if you had a unit circle, you could just look, but I think it's good to really get the patterns in your brain to sort of make sense of where these angles are and how big they are. Okay, I'm going to make us some more room to do 300 degrees. So I think 300 degrees and any of them in degrees are often a little harder to tell what the reference angles are. There's some patterns, but I think they're just generally more difficult. So again, I'm going to think about the horizontal. So 300 degrees is pretty close to 360 degrees. It's at least closer than 180 degrees. And so I would say that 360 degrees is 60 degrees away from 300 degrees. So my reference angle is 60. So again, if I take 300 and I add 60 to it, I get 360, which is 1 full revolution. So I can look at a little sketch of the graph. I know that 300 degrees is down in quadrant 4. It's almost all the way around, but it has 60 more degrees to go. So that 60 degrees is the degrees it takes to get back up to the horizontal. So here, what I really want you to be doing is to think, is the angle closer to pi or 180 degrees, or is it closer to 2 pi, which is 360 degrees? And doing this sort of thought process will really help you with the reference angles. Okay, so that is an introduction into reference angles and how we would find them. I have one more video where I go through some examples of using reference angles to find sine and cosine values without a unit circle. Thanks so much for watching, and I will talk to you in the next one.